The Hill cipher, or as some people call it, the M by M Hill cipher, is a multi-letter cipher. The algorithm uses matrix operations to compute M ciphertext letters from M plaintext letters. The operations are performed modulo 26 as shown here in the encryption process. In this equation, C is the ciphertext and P is the plaintext, and they are both of length M. The key K is an M by M matrix, and specifically for M equals to 3, this is what the key would look like. Since we're performing matrix multiplication modulo 26, we need to convert our alphabetic characters to numbers in the range 0 to 25 inclusive. The main points here are that M plaintext letters are considered at a time, and the formula will produce M ciphertext letters using an M by M key. To decrypt any ciphertext which you might have using the Hill algorithm, you will need M ciphertext characters at a time, as well as the inverse of the key used during the encryption process. The same matrix operations that are applied during encryption are applied here as well, with the only difference being that we use the ciphertext and inverse of the key modulo 26 to get the plaintext. Using plaintext pay more money with no spaces, we have to convert the text letters into numbers in the range 0 to 25. If we have the following key, matrix multiplication rules require us to alter the plaintext vector's current dimensions. According to the multiplication rules, the first matrix's columns must match the second matrix's row. With M equal to 3 in our case, the plaintext has to have 3 columns. If the plaintext is not divisible by M, you can add filler text X until it is. This is our new setup, but we will focus on M, or specifically 3 characters at a time. So starting with the first row, here are the operations that produce the ciphertext. For simplicity, you can use M characters at a time, and that is the equivalent to performing the matrix multiplication with the whole matrix all at once. Starting with the first 3 characters, P, A, and Y, these will be multiplied as follows. Each row in the plaintext is multiplied with all the columns in the key. The indices of the rows and columns are paired, meaning the first number in the current plaintext row multiplies the first number in the key's current column, and so on. After performing our matrix multiplication using the first row of the plaintext modulo 26, we get 17, 17, 11, which can be converted to letters R, R, L. Continuing with the multiplication process, we can cover all the rows and ultimately all the letters of the plaintext, and these are the results that you expect to get. The final ciphertext which you should get is RRL MWB KAS PDH. Here's a summary of everything we discussed.